Hello from once. Welcome to our today's lesson. We'll be discussing capacity, the last bit of the topic volume and capacity. You have already been taken through volume, and you know the volume is just the amount of space maybe a container has. Now in capacity, the objectives will be we should be able to state units of capacity, should be able to convert units of capacity from one form to another. You should be able to relate volume and capacity. You should be able to solve problems on capacity. Now basically, capacity is just the maximum amount of fluid a container can hold. And when we are talking about the relationship between volume and capacity, it is the volume of that particular container that this particular fluid in response will fill that particular container. For you to convert units of capacity from one form to another, you need to know of the basic units in terms of the centiliters, the deciliters, the liters, the decaliters, the hectoliters, the kiloliters. Then you should know the basic relationship whereby you have 1 milliliter being equal to 1 cubic centimeter. You have 1000 milliliters being equal to 1000 cubic centimeters. You have 1 liter being equal to 1000 cubic centimeters. You have 1000 liters being equal to 1 cubic meter. The SI unit that we expect should be referring to is the liters. Then you have the table for conversion of units of capacity. I know this is not a new table. You've had this table from primary, right from class 6. You are taught how to convert from one form to another and how to use this conversion table. I expect that at your own time you should go through this conversion table and be able to come up maybe with your own way of remembering the conversion table from the centiliters to the kiloliters. Now I'll take you through some examples, the basic ones and up to the word problems. Now you have expressed the following in milliliters. Now when you are converting from one form to another, it is important to state maybe if you are converting from, like, let's say for example here, milliliters to from liters to milliliters, we have to state that 1 liter is equals to 1000 milliliters, and when we are converting from liters to milliliters, we will multiply. So liters is bigger, milliliters is smaller compared to liters. Converting from bigger to smaller, we will multiply. When we convert from smaller to bigger, then we will divide. So we have times 1000, then we'll have 19 times 1000 milliliters. We have 19,000 milliliters. Example number 1, part 2, we have 21 liters and then 175 milliliters. They want us to convert into milliliters. Already we have 175 into milliliters already, so our concern will be 21 liters. So we have 21 liters plus 175 milliliters. We convert 21 liters into milliliters. We have 21 times 1000. We have 21,000 plus 175. We'll have 21,175 milliliters. In example 2, you can see convert into liters and milliliters. We have the first one, 75,000 milliliters. So we divide The example 2 part 1 will have 75 liters. Example 2 we have 23,456 milliliters. When we divide, we'll have 23 as whole liters, and then we have 456 over 1000. You multiply by 1000, you'll have 456 milliliters. So you'll have 23 liters and 456 milliliters. Now basically that is what we will entail in terms of capacity. If I can take you through now the rest of the examples. Now, example number 3 is a word problem, and when it comes to word problems, it is important that you analyze the question, know what is expected of you. Number 3, a water tank contains 2,225 liters of water. So that is its capacity, assuming it's full. During the day, 975 liters, 325 milliliters of water is pumped out from the tank. How much water is left in the tank? So basically this is just a question that is testing you on the operation of numbers, but now in terms of liters, so you liters and milliliters, so you need to know what is expected of you. So you have the solution. You have the difference between 2,225 liters and 975 liters, 325 milliliters. So I have arranged them. Sorry, I forgot the subtraction sign. But when you subtract, you get 1,249 liters, 675 milliliters of water is what was left in the tank after 975 liters, 325 milliliters was pumped out from the tank. In example 4, we have a cylindrical container can hold 12 liters of liquid. If the height of a container is 0.4 meters, find the radius to one decimal place, and the radius they have indicated, you get the radius in centimeters. Now, given such a question, get a pictorial representation of whatever you're being asked. So you have that cylindrical part, and then so the capacity of that cylinder is 12 liters, and as you have been directed, the cylinder is 0.4 meters in terms of the height. Now, the relationship here that now we bring in terms of relationship between volume and capacity, we need to know how many cubic meters are there in 12 liters. So we need to convert 12 liters into cubic meters, and we know that 1,000 liters is equals to 1 cubic meter. So what about 12 liters? When you divide, you get 0.012 cubic meters as the volume of that particular cylinder. Then you apply the formula. Volume is equal to pi r squared times h. So you substitute where there is volume, you replace with what we've gotten here as 0.012 is equals to 3.142 times r squared times 0.4. We don't know r squared, and that is what we have been asked to get. So we make r squared the subject. That means that we leave r squared on one side and take everything else to the other side in the right manner. So we will divide 0.012, we divide by 3.142 times 0.4. So 3.142 times 0.4 is our denominator. Now, for us to remain with r, from r squared we need to check the square root on both sides. So the square root of r squared definitely is r. Then we get the square root of 0.009548. 0.009548 is a figure that you will get after working out 0.12, then divided by the denominator, which is the product of 3.142 times 0.4. Now you can clearly see you will be required to go back to your tables, and before you go to the tables you need to write it well. So like you write it like in standard form. So I have these are 0.009548, and remember what you are taught when you are looking at square root. When it comes to square root, write your number in standard form in such a manner that the power of 10 will be even number, will be divisible by 2. So like here, if we try and wrote 9.548, we will have ended up with 9.548 times 10 to power negative 3, which basically is the negative 3 is not wholly divisible by 2. So it will force us to move a step further. So we have 95.48 as indicated there. 48 times 10 to power negative 4, but I've written it as times 1 over 10,000. Now if you look it up from your table, you'll have, if you read from 95.4, you'll have 9.7673. Then if you check 8 from the mean difference column, you will get 41. So, and that 41, the mean difference indicates that you need to add. So you'll add 0.0041. I like it when you use 0.00 something, such that you should not be confused and maybe write 9.7673, then maybe say plus 0.41. Remember that 41 should be added to the very last digits. So when you add, you get 9.7714. And then when you get the square root of the 1 over 10,000, you will get 1 over 100, basically times 10 raised to power negative 2. When you have that, you'll have 0.097714. But remember, they have said in centimeters, and that's why you're seeing I've multiplied it times 100. So when you multiply by 100, so 0.097714 is in meters. You multiply by 100 to change it into centimeters. So it will be 9.7714 centimeters. But you have been instructed clearly to 1 decimal place. So to 1 decimal place, you'll have 9.8 centimeters. So basically that is all when it comes to capacity. I would like you to do exercise 14.2, number 1, B, C, E, F, number 2, E, F, number 4, number 7, and number 8. Thank you, and enjoy the rest of your time, and continue keeping it safe.